Myself, Anjali Yadav, with my guide, Dr. S.R. Gandolkar. I'm going to present my paper topic here as accurate contouring of right ventricle for volumetric measurements from cardiac MR images. The contents of my presentation are introduction, methodology, result discussion, conclusion, and future scope. So introduction, that as we all know, cardiac assessment is very useful for patient management, cardiac disease diagnosis, risk evaluation, and therapy decisions. Cardiac MR imaging modality is standard tool which is very effective in morphological and functional analysis of heart. In this, the atrium and ventricles all are required to be assessed, but my paper is for right ventricle contouring. So right ventricle analysis is more challenging than left ventricle due to its irregular shape, and it is helpful in prediction and diagnosis of cardiovascular diseases such as heart failure, ischemic heart diseases, pulmonary hypertension, arrhythmia, and arrhythmogenic RV dysplasia, etc. But during the process of RV contouring in today's day, while the conducting cardiac MRI, at that time, right ventricle is manually located during its investigation. And this manual method is prone to intra and inter-expert variability. This can be avoided, or this can be automated with the help of different modules. So here in this paper, we are going to present our work with CNN model. In the CNN model, we have designed two type of paths. One is contraction path, another one is expansion path. The input will be given to the convolution layer, then dropout layer, then convolution, and then through max pooling. These all tools are considered here in the contraction path, where the image size is going to be reduced, but the feature extraction has been done. Now, in the path of expansion, we have designed the transpose convolution, then concatenation, then convolution, then dropout and convolution layers. Now, with the help of this concatenation, again the image is going to be reconstructed with required ROI. Now, the results are, we have been checked with the help of data set which is called as RVSC data set by Litis Lab. And these Litis Lab data set is having full cycle cardiac MR images with end systole and end diastole phases. It contains short axis cardiac MR images in DICOM format with manual coordinates provided in text format. Then we have converted that manual coordinates from text format to the image format first, so that the ground truths will be prepared. Then evaluation parameters of our model we have been selected as blood volume at end systole and end diastole level. The volumes are computed as sum of all areas multiplied by the value of space between slices. Blood volume is nothing but sum of all the area which has been selected as a systole phases or diastole phases into space between slices, where space between slices is nothing but absolute difference between slice location in the DICOM fields into adjacent frames. And these ESV means these blood volumes, ESV and EDV, are going to be used in the assessment of cardiac function and calculation of ejection fraction and stroke volumes. And EDV is used to estimate preload of the heart and to estimate ejection fraction and stroke volume of the heart. Now, by using these blood volumes, ejection fraction is going to be calculated. Ejection fraction is nothing but EDV minus ESV upon EDV, which is going to be used to determine how well the heart is pumping the blood. Now, this whatever ejection fraction parameter we have been calculated with the blood, with the help of blood volumes. In the case of male, the normal ejection fraction is going to be considered as 52% to 72%, while for female 54% to 74%. For mildly normal heart, 41% to 51% and 41% to 74%. And moderately abnormal patient will be considered when ejection fraction parameter has been considered from 30% to 40%. And severely abnormal patient will be categorized whenever the ejection fraction will be going below 30%. So whatever the right ventricle contouring I'm saying here, that is nothing but this crescent shape given in the diagram. And if any abnormality has been occurred, then the shape is going to be changed like this one. So with the help of accurate contouring of right ventricle, any cardiac diseases will be identified which are based on functional and anatomical assessment of the heart. Now for our CNN model, these are the hyperparameters selected where optimizer has been selected as ADAM and SGD. Loss function, binary cross entropy. We have been achieved training accuracy 0.99 and the loss is 0.01 here with epoch number 25 and batch size 16. So these are nothing but the hyperparameters. Now our CNN model has been trained with the help of two optimizers. One is SGD and another one is ADAM. For HDD, if we will say the blue color lines are not showing the validation loss and orange color line showing training loss. And here also same the things. And we can say ADAM optimizer is working properly or it gives good performance response because the training and validation loss are converging itself. So that's why for further processing, we have selected ADAM as an optimizer. Now the results of the both optimizer training are shown here, that the right ventricle contouring is quite distorted with the help of HCD as compared to ADAM optimizer. So conclusion of this paper presentation are nothing but accurate contouring is a crucial step in blood volume measurement of right and left ventricle. The proposed convolution neural network is used for precise identification of right ventricle. Our model with ADAM optimizer provide 99% training and validation accuracy. And in the case of end systole volume and in diastole volumes, 93.27 and 90.28% accuracy we have been achieved at endocardium boundaries of the cardiac short axis MRI images. We can say the future work of this particular work is nothing but a whole quantitative analysis of right ventricle as well as other part of the heart are required to be extended so that we can assess stroke volume and volume mass index for estimation of complete heart volumes without any manual intervention. So these are the references and thank you.